Okay, everyone. I wanted to show you how we can work with correlation in Microsoft Excel. So the correlation coefficient calculation is a little bit cumbersome. It's easier to let the computer do it and probably more accurate to do so as well. I wanted to mention, I'm not going to show you how to do this Spearman's row, the ranked order correlation coefficient. This isn't all that common. And if you get into a situation where you need to do it, you're going to probably be using software that's even more robust than Microsoft Excel for that analysis. Anyway, this data set is available up on Canvas. It is a data set from an NSF-funded project that looks at how land conflict might be correlated with deforestation in the eastern Brazilian Amazon, right? So these data were put together from a variety of sources, from satellite image analysis using Landsat 5 data, and then also newspaper archive analysis covering about 8,000 newspaper articles written in 2 different newspapers in the southeastern part of the state of Pará. So anyway, I wanted to show you the three methods where we can investigate correlation interactively in Microsoft Excel. So the first one is the scatter plot. So Excel is good at doing scatter plots. We'll go ahead and do a little bit of a test here. So let's go ahead and see if rivers are correlated. The distance to a river from the center point of a property is correlated with the distance to a major highway, right? So we would kind of expect highways to follow along riverine corridors because they're probably fairly flat. But let's see if that, so rivers, we would say closeness to river is probably going to determine, well, let's pick something else. Let's say closeness to river and the amount of forest in 2002, right? These are 2 variables. We would typically expect that properties closer to rivers are going to have more forest because it's a pretty serious environmental law in Brazil that you not cut down forests right next to rivers, right? So I'm going to go ahead and select those 2 columns that I want to make a scatter plot out of and go over to the Insert tab here and then go to my scatter plot command. Now, Excel is a little bit unpredictable with what it will decide to put as your x-axis and your y-axis. I'm going to guess that it appears to have put distance to river here as our y variable and our x variable as our roads. We want this to actually be switched around. And so what we're going to do is in our select data, we're going to edit our data series for this. And we're going to choose our x values, which are our independent variable. We want to make sure those are rivers, and they're not, right? So we'll go ahead and select that column. And then we want to make sure our y values, our dependent variable, is there, is our forest cover. So go ahead and click OK. OK, and we'll go find our chart here. And we can see now we have our distance or our forest cover values in hectares and our distance to river in kilometers. And so we have an interesting relationship here. It almost appears like there's a wave pattern, which means that we might want to be careful about using a coefficient or a simple R here, but this would give you a nice way to diagnose whether there's that nonlinear relationship, which we'll talk about more later this semester. Now, in scatter plots, you do have functionality in Excel to go beyond what we're talking about this week and add a trend line to our data. This looks like a linear, if we say this is a linear trend, it is a decreasing trend, where as we get away from the river, we have higher values away from the river, we have less forest cover, and that's what we would expect given the law, right? And we can get into those non-linear trends here, but we're not going to worry about that. At most, we'll do linear relationship here. And we can see this is looks like a fairly weak negative correlation, right? Now, we might want to use a different way of looking at correlation, and that is, and we might want to make, our chart here a little bit more easily interpretable. And so I'm going to add a couple elements here. I'm going to add some labels to our axes. I'm going to set this up to be distance to river and put it in kilometers. And then here, 2002 forest cover in hectares. hectare is about 2.2 square acre or 2.2 acres. And and then maybe title this forest cover is higher near rivers, something like that, right? So there's our nice chart. We could mess with our styles and colors and whatnot, but we're not going to worry about that for this demo, right? So that's a scatter plot, one way to investigate the kind of relationship between two different variables. Now, another way would be to use the correlation coefficient itself. So that is a formula that we can use. I'm going to say correlation between distance to river and forests in 2002 or 2002, right? And then in the next open cell, I'm going to type in the formula for correlation, which is just CORREL. And then I have to select my distance to river variable and comma, my forest cover variable. Close the parentheses, hit enter. And so I have, it looks like when my correlation between distance to river and forest is a slight positive in this case. But if I run the same correlation coefficient, but change the order, let's see what happens. I get the same value. That's good, right? So the linear relationship between the two may appear negative because there's all this noise up here. Remember from the PowerPoint presentation, we have, in case where we have noise, the correlation coefficient is going to be closer to flat. And that indeed is what we get. Our correlation coefficient is a positive correlation, but very weak, really pretty close to a flat line, right? So these are the two of the three ways that we can explore correlation in Microsoft Excel with quantitative data. The next way, though, is maybe for when we want to look at a lot of different correlations at once. So to use this, you need to have the data analysis tool pack enabled. Just as a refresher, click on File, go to Options, go to Add-ins, click down here next to Excel add-ins, click Go. Make sure Analysis Tool Pack is enabled. If you do this once on your own computer, you should not need to do it again. On our lab computers, you will have to, unfortunately, do it every time. Go ahead and click the Data tab over here, and the Data Analysis button should now be available because of that action you did here in the File Options menu. On Data Analysis, we have correlation as a example here, or as a tool here. Go ahead and click OK. And now all we have to do is go ahead and select a group of columns in this case, and we're using columns because we've said we group them by columns. Each variable is in a column that we want to see if there are any correlations. So I'm going to select a large number of columns here. I'm going to go from hectares all the way to environment, which is environmental violation. And I'm going to output this to a worksheet called core. Now, let's see, there's non-numeric data somewhere in there. Let's see what's happening. So we have hectares. We'll go ahead down. Oh, I know why. Because of the data that I had done before, it included the text correlation coefficient. So we'll go ahead and go ahead and do this, just manually make sure it's all there. And that's going to calculate a very large table of correlation coefficient values. So to make these a little easier to read, I'm going to select them all and just do a little bit of formatting. I'm going to set them to be 2 decimal places. And all these are, and then I'll zoom in a little bit so we can compare them. The other thing I'm going to do is freeze my panes so that I always have these labels. View, freeze panes. And now I can scroll down and I know which column and which header are, which column label and which row label are corresponding. So the way we read this is Forest 1996 is strongly correlated with Forest 1999. Now that's not a shocker, right? These are all going to be highly positively correlated. If forest is high in 1997, it's going to be high in 1998, and it's going to be high in 1996 because there's temporal and spatial autocorrelation, right? Which we've talked about briefly. We'll talk about more later this semester. However, there are some negative correlations here. For example, there is a negative correlation between something like a weak negative correlation between a threat of occupation and weather and distance to a major highway, right? Meaning that As you get further from a highway, the odds that your property is going to be threatened with a property occupation is actually going to go down. Now, this is all fine and great, except that with all these data values, it would be nice to highlight which values are positive, which ones are negative, and which ones are strongly so. So we're going to use a little trick in Excel called conditional formatting. I'm going to select all these cells in our table. And in the Home tab, I'm going to go to conditional formatting and then color scales and select this green, yellow, red color scale. Now, any strong positive correlations will show up as a strong, deep green tone. Any strong negative correlations are going to show up as a strong red tone. And the medium values in between, both positive and negative, will either be yellowish, greenish, or orangish, reddish, depending on the intensity of their negative correlation, right? So this is another way to investigate the correlation between a large number of variables. Let's say that we came up with one that had a strong positive correlation. For example, Forest 2002 and Forest 1996. Now, obviously, these are correlated because they're going to be similar to one another. But we might say, let's pretend these were different variables. We might, that didn't have an obvious connection. We might want to then explore them, use the correlation coefficient table here to explore them in a scatter plot, right? We already have the correlation coefficient, by the way, it's 0.96, highly positive. Forest 2002, Forest 1996. I find those, Forest 1996, and then Forest 2002. Oops, Forest 1996, Forest 2002. Select those, and I can make a scatter plot out of them just to see a strong positive correlation scatter plot. There it is, right? We have one on one side, one on the other. As one gets high, the other one gets high. That's what a 96 correlation coefficient of 0.96 looks like, right? So in reality, we might find some interesting correlation here in this table and explore it more through different analyses. But this would be kind of three ways to implement correlation. We have our correlation table, which we create using the data analysis tool pack. We have scatter plotting, and we even have our correlation coefficient calculation using the Corel Microsoft Excel function. Go ahead and check out the activities in the week, I think it's week 12 folder on Canvas, and I'll see you in person next week.